In this video, we're going to show you how to generate a ZAERO or ZEUS BODY7 model, starting with another model, either with an IGES file that you mesh into triangles on the surface, or for example a CFD surface panel model. In this case, we're going to demonstrate it on an A10 fuselage, and we're going to load the file, which in this case happens to be a geometry definition file that ends with the extension OBJ. So we can load that here. And once the file is loaded, then we see the model. So we can go to the controls view to orient the model any desired view. And to generate this fuselage model, the first thing we're going to want to do is orient the vehicle so that it's in the proper frame for generating an aero model for ZAERO or ZEUS. For example, the nose of the vehicle would have to be located at 0, 0, 0 in the global coordinates, and the right hand wing has to go down the positive y side as it is in this case. However, if we look at this particular point here, when we go to the plot menu, work plane, we can see that the y goes from 12 to 236, so it's not positioned at the 0, 0, 0 location. So the first thing we want to do is orient the model in the proper location. And the easiest way to do that here is we can just select a node, and you'll see why we have an option for this later. So if we click here at the nose, we see down here that it is currently located at 52.6 on the X, 124 on the Y, and negative 0.89 on the Z. So then we turn this off, and we're going to go over to the Tools menu, the Alter option, Alter Data, and here we have options. So if our model happened to be down the wrong axis, you can use one of these. For example, swap X and Y coordinates, and this is an easy way to rotate your model. In our case, the model doesn't need rotation, but it does need a shift. So we're going to select to add to all of the model nodes, and then we have an option here, last selected node. So since we had clicked on this nose point earlier from the ID on off pane, we can click here and it'll just import the values that it had selected. Now since we want to move it in the opposite direction from all these coordinates, for example X minus 52, Y minus 124, and we'll take out the negative here for the Z. So then we click apply, and now the model is oriented. If we go back to the work plane, we can see that indeed it goes from minus 111 to, or minus 111 to 111 on the Y. So it shifted the model so that the origin is at 0, 0, 0. And likewise, we can see that here. This is X equals 0. So once we have the model in the right place, what we want to do then is save the model into a format that a convenient format that we can read back. And oftentimes this is just simply a BDF file or a Nastran bulk data input. So we can go to the Home menu, Export tab, simply select bulk data and export, and we'll give it a file name, and we can call it a10.bdf. We save the file. If we want to view back the file that was saved, we can create a new document, go to import. This time we choose Nastran input output using the Zona Nastran data loader, or Zendal. We choose Nastran bulk data input deck, and there's the A10 BDF that we generated, and we can just load the BDF, and we see it's the same model, but it's just saved in a different format, and the origin now is at 0, 0, 0. Okay, so the next step now, I'm going to restart ZONA-MV, And what we want to do is import, once again, I'm going to import that Nastran model that we generated of the A10, called A10 BDF. And now, the next step is that we want to remove all of the panels or elements that we don't need, that will also help us then to generate the BODY7 or fuselage model, so we don't have to deal with all of these extra panels, for example the wings and the horizontal tail. Now that being said, it can be generated with these components on. It's just that it's much more difficult to do so. So I'm just going to show you here how to remove everything that we don't want and end up with a new model that just has the fuselage model, from which we can get coordinates that we need to generate the BODY7 model. So we can look at the model from the top here, and oftentimes if we have a symmetric panel model, which we don't here, you see these triangles, we could actually cut the model right down the middle and just delete everything on the left hand side here and just operate with the right hand side. But in this case we can't, because we don't have a nice clean cut line on this panel model that comes right down the middle here. So if we do chop everything off, it's going to be all blocky here, and we're not going to have a nice edge that we can grab onto. So in this case we have to keep and retain the entire fuselage, although we're only going to generate a half body from this model, which is easier for us to work with, because in the end we want a symmetric model anyways. So we'll see that when we get there. So right now what I'm going to do is I'm using the right mouse button to pan, the middle to zoom, and the left to rotate here on the controls view. Then we can just set the orientation. Now I'm going to go over to this Show Hide Elements pane. We're going to turn it on. I'm going to select Box, and I'm going to come over here close to the fuselage, but I'm not going to touch it. And I'm just going to drag a box with the left mouse button and let it go like this. So this way it's going to select all the panels that it could within that box, and then we're going to click Hide. So we removed the first chunk. Now we want to come in and remove all these extra pieces that are hanging about here. So we can select panels like this from the top and click on them one at a time, or you can hold the Shift key and just move your mouse, and as you can see, it'll highlight all these panels that the mouse is over. Now you got to be careful that you don't end up selecting panels on the fuselage, because we don't want to remove those. So we just want to remove all the ones around the fuselage, or even inside the fuselage, which we're going to look at in a little bit here. So this takes a little bit of effort here. We're just going to go through this and basically erase everything we don't want, and we can zoom in on certain areas to make it easier. Here, so oftentimes if you can grab a box or a polygon around something, then you should do that, because it'll get all the elements, including the ones beneath it. So here I'm just holding the Shift key and moving the mouse so I can highlight all this stuff. Okay, and this is the process then that we're going to keep doing until we clean everything off the fuselage and the horizontal tail as well here. Want to get rid of all this. Okay. So I'm going to pause the video and go ahead and clean up both sides in this fashion, and then return so we can continue, and I'll show you how to clean up the inside of the vehicle in case you have elements on the inside. Okay, so once we have the wings and tails removed, and the gun from the front, which we're not going to model also, then we end up with this model as shown here. Now we want to ensure that there's nothing inside the vehicle as well. Otherwise we need to remove those. So we can use the dynamic clipping planes to open up the model, and if I pull the y-axis from the positive y, we see it opens up here, and indeed there's some internal structures. As you can see, I'm highlighting these panels. So what we want to do is remove those so that when we slice this model to extract surface coordinates, it's not also picking up the internal panels and giving us slices inside, which gives us more work downstream. So to clean this up is basically the same as before, but we're making use of the dynamic clipping planes to open up the model. So here we're just going to select the panels that we want to remove. Again, be careful not to select a fuselage panel. If you do select one like this, click it again to unselect it. If you happen to make a mistake, you can always undo over here the last action. So if you make one mistake, you can undo it. If you make more than one mistake, you have to reset and then recut away all the elements that you don't want. So we can just do this procedure here and just keep hiding. Again, you can also hold the shift key, but it may be dangerous inside here because you don't want it selecting panels that you didn't intentionally mean to remove. Now in this case it's okay. I can get away with this because there's panels underneath. And see here, now I opened up the fuselage, so I'm going to undo that and I'll have to reselect these. So you have to pick these panels and then just remove them like this until we clean it up. So I'll just go ahead and pause this video and remove all the internals. And also one more thing we want to do is on the aft end of the fuselage here, we're going to cut away this little back piece by looking at the model from the side, and then going to the show hide elements box, and I'm just going to select this region and hide it. So we're going to leave the model open like this because ZAERO and ZEUS require that the aft end of any fuselage be opened up. So we had a good location there. We can just open this right up. All right. Okay, so once we've cleaned up the model from the inside and removed the aft end, I like to save the BDF file, which I did, and then restart ZONA-MV. So I'm always starting from a clean slate. And then here we can also see when we look down the fuselage from the rear, we see that all those internal panels have been removed. So we end up with a model like this. Now the next step is that we want to create slices. And now this is how do I say this? Not a necessary step, but it's a step that you're going to use because it's the easiest to get straight lines down the fuselage. In the end, what we want to do is generate these segments on the segments pane. And if I turn this on here, we're going to generate a series of lines that go in the streamwise direction along the fuselage. And the program will generate panels circumferentially based on those streamline lines that we define here under segments. Now one of the options for segment is you can add segment data point by point, so we can actually draw our own lines, but we have to rely on the existing nodes on the existing surface panel model. So if we want to interpolate to get nice straight new lines based on the surface, then we need to use the slice option first and then come back and create the segments based on those slices. So that's typically the best way to do this, and I'm going to go ahead and show you how that works. So come to the slices tab. You turn it on, you see the plane control, and we're going to change it to the Y plane. And then here the position defines the coordinate. We're at -8.28. Now you can either use this button to select the location or you can type it in. Either way works. I know that I want to go through the nose point first, and if you come back here you see it's at 0, so we could have typed in 0 or selected a point, but oftentimes it's nice to be able to select a point from your display model to position the slice plane. So the first slice that I always start with is the one to get the top of the model and the bottom of the model. So since we're at the right location here, we can go ahead and say extract slice data, and we look down to ensure that the program generated the slice, and it says it added a new zone. with the number of 198 nodes and 99 elements. If you turn the slice plane off, you'll see this line that's added here, and it'll actually cut through and interpolate across the panels all the way down. If you ever want, and you can also see it here on the bottom side, goes back, and it's overlaid by these other lines. So if you want to get a clear view of it, you can always go to the controls view pane, and under zone settings, turn off the original model. So I'll turn off the zone show here, and we'll leave the slice plane zone that we just added, and you can see the outline of the slice that it just took. And because we removed all those internal panels earlier, we don't have lines on the inside. So that was the reason for doing that. You can click on the nodes tabs, and you can actually see where the nodes are from the elements that it interpolated to get these lines from. Okay, so we'll turn this back on, and we want to go for the next slice. And the idea is we're going to generate slices all the way around the model, and our focus is on this on the right hand side of the vehicle, because that's what we're going to end up generating body segments for, from which we generate the BODY7 model in the end, even though we have this other side still sitting here. If we have an asymmetric model, then you would have to make sure that you get body segments on both sides of the vehicle, and the program can generate a full model from that as well. So either way, but if you have a symmetric model, it's always easier just to do a half. It saves you a lot of time. Okay, so we go back to the slices plane control, we turn it on, and now we have to make a decision what we want to do. In this case, I'm just going to use every 15-degree increments, and then we're going to add a couple extra ones at 7.5 degrees where we have a lot of the bubble here on the canopy, and we want to try to capture that shape. So I'm going to reposition the plane back at 0, and then I'm going to go on the slice plane control and choose arbitrary, and we see now that the plane has a normal vector here that points off onto this side. We want that normal vector to be located at 0, 0, 0. So I'm going to just click in the origin box here and move the point to this location, and leave my normal vector the way it is, and I'm going to change the step angle to 15 degrees, and then I'm going to click about the x-axis. That'll rotate this plane about the global x. So if I do that, we see then that this becomes a 15-degree slice location. So we can take a cut here and say extract slice. Now, once in a while, and it doesn't happen too often, if you get a message here that the determinant is 0, it means we need to nudge the plane coordinates, because numerically it's picking up points off of this plane that are coincident, and it can't get the determinant. So we just need to nudge it ever so slightly. One way to do that is to say, okay, I'm going to change my degree increment by 1 degree, and I want to actually have this a little bit higher, so I'll just move it up 1 degree, and then I'll try again. And you see now that it was able to extract the data. So that doesn't happen very often, but if it does, that's the way that you can get around it. So this was our second one. Now if I go back 1 more degree to where I was, set this back to 15 degrees, then I can drop down to my next 15-degree location. Now in the end, our objective here is we want to capture the shape. So the difficulty in shape for this model comes from the canopy region. So there's 2 issues excuse me, with the canopy that we have here. The first one is that we want to capture this edge over here, and the second one is we want to capture this flat face for the windshield. So the way we can do that is we're going to generate a line that comes up here and over, and we're going to generate a line that goes along this edge here to the back. Now, one thing to keep in mind when you generate a ZEUS model, you cannot have a straight edge like this to the Y direction. So if we look at this, we observe that this guy is pointing right down the Y. So one way to get around this so that we don't have any meshing problems later is to just create some angle here. So we're going to, later on when we draw this line, we'll go from this point over and then up. Okay? And another thing, right now where I'm cutting here, I'm very close to this position. So if I actually want to have this line come and mate up with the canopy right here, one would ask, well, how do I do that? I could specify a small angle and keep trying to get closer and closer, but there is another way. And one trick that I would use is if I come back here, I say, okay, the back end point is roughly here, right? So I can grab this point on a 3-point plane option, and we're going to see that in a second, which is 1, 2, 3 lines down from the last blue slice plane. So, and I have the origin here, and then I have that one point right here, which is the furthest point out. So I'm going to go to 3-point plane, and I'm going to click on this first point and say, okay, choose the nose point. I'm going to click on the second point, and I'm going to go right over here, choose this point, and then I'm going to choose, click on the third point, go to the back end, and go 1, 2, 3. I'm going to choose this point here. Then I can click Update Plane, and I see that the plane is cutting through nicely right on that corner so that I can have the lines merge later. And I'm going to extract the slice data. So if I turn the plane off, now we see we have this nice line right down here. Okay. Now we can get the rest of these by just continuing on 15-degree increments, and then we're going to have to do a little adjustment here to get right along this edge because we want to capture where this edge protrusion is maximum. And then we'll just continue down until we reach the one line right before the center line, right here, this blue line. So we'll come back. The way I like to do this, I go Y plane, go back to 0, then I choose arbitrary, I move my origin back to 0, so I'm right here, go 15 degrees, and now my normal vector is all correct, and I can just drop 1, 2, so here's the next one. So we can extract slice data here. Again, it's giving me a little bit of a determinant problem. I'll just add 1 degree to it, and now we have that slice. So I'll move that 1 degree back, go another 15. Okay, so now we go down 15 degrees, and for some reason I keep having trouble. I'm gonna have to play this game. Okay, 15. So it grabbed this one, drop another 15, it grabbed this one, drop another 15 degrees, and then it's an issue, so I will just drop this one actually down 1 degree. Okay, it picked it up. Go back to 15, and drop another one. Okay, so now we're getting close to where that line was, and we'll use a 3-point plane to pull out a nice line from the nose right along this edge to the back. So I'm going to go look where the plane currently is, and it's on this line, red line right here, which is one under the blue, so we know which one to grab. So I go up to 3-point, point 1, choose the nose, point 2. This time we're going to have to identify where the line that we want. We could go along here, but it won't be deep enough. So we might be better off going here at the bottom corner point, and then click point 3, go to the back of the vehicle, and again come down to one below here. Now we say update plane, and we go take a look at this, and you can see where the plane is now cutting through. So we can determine, is that where we want to be, and if it is, then we can click extract slice data. It picked up the slice. We turn the plane off, we see we have that nice line here. And then finally we're going to need one more through here. So I'll turn the plane back on, go back to arbitrary, move the origin back, and we're going to drop another 15 degrees. So now we'll be located here. We take a look at it, so it looks good. So we can extract that, do another 15 degrees, and now this will be the last cut, I believe, on the bottom. So I'm going to cut that one out. Let's see if we go one more 15. Where are we at? Nope, there's another one that we need before we get to the end. So we extract this one. Okay, so now if we turn off the plane control, we can take a look at the lines that we have from the slices. Again, I'll go to zone settings, turn off the model, and this is what we currently have. So the next step after this is we want to capture a couple extra lines up here in order to make sure we get the canopy correct. So in order to do that, I turn the model back on and go back to slices. And it would be nice, because if you look at the distance between this line, this dark blue and this light blue, we have a huge gap here. So we want to create a cut through here, and we also want to have this line to define this front window. And we need another one here because we have a huge gap between these two lines, and we're going to need a line along here. Now this line and this line we can manually set up in the segments, so we don't have to create any slices here to do that. But we do want to get these two slices so that we have these lines that go all the way down when we set up the segments later. So we'll come back, turn this guy back on Y plane. It's easiest just to go to 0 and then go arbitrary. Again, change this origin to 0, 0, 0. Change this 15 degrees. Okay, so this time I'm going to change 15 to 7.5 so I can cut in between. And now I'll be cutting right here in between these two. And we can look at it and say if we want to adjust it up or down. I won't. I'll just use that. And then I'll go another 7.5 and another one. So then we're cutting in between these two. Now if you look at this one, we could say, well, you know, it would be better to come up a little bit here because we're kind of closer to the yellow here than the blue, just based on the vertical drop on this canopy. So we can say 2 degrees and then move it up, and if we like that we can cut it, but what I'll do is I'll just drop it 1 more degree down and say, alright, that's pretty good, that's where I want to be. So then I'll extract my slice here and I have it. So at this point we want to save our model. Make sure you save your work. There's a save button to save. We're not exporting this time, we're actually going to save the entire ZONA-MV information that's in here. So we click on this save and then we give it a file name, for example A10 body, okay, and we say save. So now we've saved the file, so we can load it back exactly where we left off. So in the next segment I'm going to come back and show you how to set up the body segments. Okay, so now I'm going to show you how to generate the body segments from the model that we have sliced. So I'm going to start ZONA-MV again here, and we're going to load the ZONA-MV file that we saved last, which was called the A10_body. And so here's where we had left off on the model. So in order to add segments, what we want to do based on these slices is to auto-extract the data and put them into the segments. So we go over to the Segments tab, we turn the segments on off, and we click Add to add a new body segment line. Now at this point, whenever you add a new one, the number of segments is 0. So this particular line, these options here, I'll explain them in a minute. So one option that we have to add segments is simply to highlight the entry, click on Add Segment Data, and then click on, for example, I'm going to give you an example here, click on 2 points in the model. So you see this green line that appears here, and you look up in here and it says the number of segments is 1. So we added a body segment with one single segment, and that's shown here. If we want to delete it, now what we can do is click on this delete button. So and whatever action you do, you have to make sure that you first highlight the entry in the line segment data so that the program knows which one you want to affect. So if we want to delete this, I can choose this delete segment option, click here, the segment's gone, and it updates the line segment data, so there's 0 segments on that line. So, or you could simply highlight the entry and then click delete, which will completely remove it. So that's one method for selecting segments within a line segment. Now, since we created these slices, the first one we want to start with to get the data from is the one that goes up over the top and down under the bottom of the fuselage. So I'm going to highlight this entry, which has 0 segments in it right now. I'm going to drop the list to the first slice plane that we created at y = 0. So we're going to select that, and then we're going to click this From Zone button. Now you see up here it added 65 individual segments within that line segment. And when I click on it in the line segment data list view, it highlights the line that it created on the model. Now we want to define each line individually. So the first one, I'm going to do the top one over the top of the vehicle, and because it selected this on the bottom, we're going to have to remove that. So what we can do here to make this easier, well, there's several things you could do, but I'm going to turn the elements off and turn the shading off. I'm going to go back on the Controls tab, go back to the Segments tab, highlight the segment. Now here you can double click, so you see where it says lines. If I double click, it turns the show lines off for this particular segment. If I double click, it turns it back on. If I double click on show points, it shows me the interpolated points. Now these will coincide with the ones that were on the slice itself. So I like to leave this on when I'm cleaning up a line segment, and we see we want to remove all these ones on the bottom here until we get to the nose point. And we may not know exactly where the nose point is, so I'll turn the model back on to see that. But I'm going to select the line segment here, select delete, and then I can delete each one of these segments on the bottom so I can just get the top line. You can also hold the Shift key, and that will as you move the mouse over the segments, it'll automatically delete them. So this is pretty useful feature as well. You can zoom in when you need to. I'm just holding the Shift, getting rid of these. Now I don't know exactly where the nose is, so what I'm going to do now is go back to the Controls view. I'm going to turn the elements and shading on. Now I can see where it is. I'm going to go back to the Segments tab, make sure this one's highlighted, and then come in here. Again, I'm going to hold the Shift and delete all these on the bottom. And okay, so now if we zoom in, so we're starting from the nose point. So now we turn this off, which is the deleting option, so we don't end up deleting points continue deleting points. And I'll turn off the show points here, and if we turn off the elements and shading, we can see that we have this line taken from the slice. Now, because the panel model isn't perfect, we have a little gap here, and ideally we want to get nice perfect lines for each one of these lines. So what we can do is close this gap here by going back to the segment stamp, line segment data, and I can just manually close this and delete this segment. So it'll be a slight approximation at this point, but that's fine because we want to make sure that if the program happens to be interpolating a cut at this station along the fuselage, we want to make sure that there's no opening here. So what I'll do is I'll select this line, click delete, I'll just pop out this one little piece, select the line, click add, and then I'll just go from this point. You see when it pops up here, it shows you that it's selecting a segment point as well as a node point in the model, and they're both coincident to here. So I've closed that up. Okay, turn this off, turn off the show points. Okay, now we have one nice clean line segment to define the top of the vehicle. So we're gonna go back and turn on the elements so we can see the slices, and I'm going to go to zone settings and turn off the model, and now we're going to continue this process and generate a line segment for each one of these lines that we have all the way around the fuselage for the right hand side only. And I can use the same process by going to the line segment data, adding a new one, and then selecting from each one of those slices and removing any points along the line segment that we don't want. So I'll go ahead and do that, and then we'll continue from that point. Okay, so now we've generated all of the line segment data that we wanted to capture from the slice lines. The slice lines are shown here, and it's a good idea to save the file. So here I'll click. We have 15 line segments defined. We can jump through them by clicking in the line segment data list view and then moving the mouse down, and you see that it highlights each one of those line segments in the model view, and we've only used line segments then on the right half side of the model, which is all we need since it's a symmetric model. So it's always a good idea to save your input at this point, and what I often do is do a save as, and then I will increment the number so that I have another copy of the data at different stages of the work. So that way, if something happens and I want to go back to a previous stage, it becomes easy to do so. So I can save this as A10_body3, and it shows you here at the top which version you're working on. Okay, so at this point, we're going to have to add a couple more line segment data on the model in order to capture the canopy region. If I come over here on the zone settings window, you can double click to turn these zones back on in the zone show. So the first two are the C-Quad 4 and C-Trio 3 elements. So here we see it again. So the canopy region, in order to capture this shape and this edge, so the shape on the window and then the this curvature on the canopy, we need to define a line there in order for the program to be able to cut through that when it generates the panels. So what we can do, and it's always best to stem from a single point. So we don't want to have, for example, 3 lines coming through this area and none of them intersecting. When we define our SEGMESH, we need to define a starting and ending position, and it's always good to have all your lines coming together at a SEGMESH point or branching out from that same x-axial station. So we can do that here, and if we want to start it from, let's say, this point here rather than this point, because if we start it from this point, we have a line that's in the Y direction, which is never good for generating a ZEUS model. ZAERO can handle it, but for ZEUS it's not. We have to have some angle in here. So we could have just as easily started from one of these points, but I'll just go ahead and start from this point back here, since there's a gap, and we can just get rid of that gap at in one shot. So we go back to the line segment data tab. I'm going to click add. So we add number 16 here, and I'm going to click on this button to add the segment data points, and I click here on this point first, and then I'm going to come around on this edge. So I'll click here, and then we'll go up the front windshield region to create a line. And you don't have to pick every point, you can. In this case it's a fairly coarse model, so it's not too bad. And then on this last one, I'll just jump over and cut it off, let's say at this second tier here. Okay, so we have some angle there. We're not going straight across. So that will be this line. And if you ever want to change the color of a line, you just click on this color bar, and you can click different color, say OK, and it'll change that color. Again, click 3. If you want to take the highlight off, click 3 times in the white space, and that'll take the highlight off, and you can still see the line here. Okay. Now we want to create one more line that branches from this point and goes along the edge of the canopy, and we also want to connect here at this point where we have where we previously set the slice through that point. So I'm going to add one more line segment, select it here, maybe change the color to something a little darker, and then make sure it's selected. Click to add 2-point data, and then I'm going to come down here and I'm going to start on this point, and I'm just going to run along this edge, and I'm going to make sure that when I get to, again, you can select every one or you can skip. It really depends what kind of accuracy you're trying to get. So I'll just click here to make sure that we intersect, and then come across the back side of the canopy. And another thing that would be good is to have an intersection point here in case it's needed later. So I'll just go ahead and pick that, and I'll rotate the model so we're looking a little bit from the top. So I'll come to this point, and then we'll jump over to this point here. Now this will have an angle here. If we want to minimize that, we could use the slice plane to create a slice through this area, and that would give us a point that's closer, and then we would be able to extend this line off of that point. But for this demonstration purpose, we'll just leave it coarse and then jump over to this point. Okay, so you can't see it because it went underneath those panels, but that's where that line is. So we'll turn this off. Okay, and now we have the lines that we need in order to be able to generate the body panels. Okay, so now is a good time again to save your input one more time. And when we look at this model, we can turn off, go to the Controls tab, turn off the elements and shading, and we see the line segments that we've defined. Now, looking at this, we can see that one option here is we don't need to keep this particular pink line in this region, because then when it generates the panels, we're going to have all these little panels in here. So, but we do want to have the line up on this back region, because otherwise the gapping is too big and the panels become too big here. So what we can do towards that end is eliminate this pink line in this region. So we come over to the line segment data, we identify which line it is by clicking on it, and okay, so it's the second one here. I like to double click to see the nodes where they're at, and then so make sure it's highlighted, select delete, and then we can take out these points. Again, you can hold the shift to remove. If you need to zoom in, and use the right mouse to pan. Okay, so we can pretty quickly clean this up and remove these extra points. And you see there's one that's down in here, so we want to make sure that we take that one out as well. Okay, so now we just have, I'll turn it off, turn the points off, click in the white space 3 times. Okay, so now we have this. So to generate a panel model, we need to define segments. So the way I normally do that is look for a starting point and an ending point, and it's always where transitions occur. So here we see that we're starting from the nose. So I'm going to add a SEGMESH down here, and by default everything is 0. So we want to give an X coordinate, and the way to do that is you just double click on the start entry, come over here in the model and click on the nose, and we see that it's 0, which of course is what it is. And then we want to bring that up to the first transition point, which is here. So we're going to double click on the end point and then click over here on this segment point, which is at 15.7. And then we specify how many cuts do we want in this region. So we can say, let's do 9 cuts. Now, circumferential control by default is auto, and you can set this to a user-defined selection, and we'll look at that in a little bit on how to do that. So user-defined simply means that you specify which lines you want the program to cut through, as opposed to the program trying to figure it out on its own. And oftentimes this becomes important because the automated process will do it based on angles. But if you happen to have a weird geometry that has, for example, a strake that actually bends down, it'll pick points from the top surface before it picks points from the bottom surface, and you'll end up with a panel model that was not intended. So that's why we have the user option. But in any case, for auto, if you want to check the panels that we're generating for this SEGMESH, you can do that at this point. We select first of all full from half because we have a half model, but we're going to generate a full model. Make sure preview is on, and we're going to output ZAERO multiple SEGMESH, and we're going to output to the data tab, which means this tab here. So all the bulk data that's generated will be output to this tab. You also have an option to output to a file if desired, in which case you would select this, which we'll do towards the end. But for now we can just output here, and then we can say, if we select a SEGMESH, right now we select the first one, we can say generate current SEGMESH. So if we click that, we see then in the view that it generated 9 axial cuts for this segment, starting from the nose and going to here, based on the line segments that we've defined. Now we see that, you know, for example, this is a little coarse because it's doing an even distribution of cuts. So one way we can improve this curvature in this region is simply by increasing the number of cuts. So for example, we can say 11 here, and then regenerate the current SEGMESH, and it ends up like this. Now, there's limits to that. Of course, we can just keep increasing this, but then we generate a lot of body panels, and that takes extra computation time. So there's a balance. We want to have a refined enough model to capture things like the reduced frequency that we're running and so on. But we don't want to overdo it, because if you overdo it, you're just wasting computing time, and it's much better to, you know, for example, waiting a couple hours than to get the results rather than waiting a day, which can happen easily if you ramp up the number of panels. So one way to get around this kind of thing is, if we want to have more cuts in this region, another thing you can do is add these so-called additional hard points. And what the program will automatically ensure that you get an axial station cut at that location, and then it will subdivide the open areas from largest to smallest in half and keep halving until it reaches the number of cuts that we've defined. So for example, if we want to add a point here, now you can add this way by manually inputting a value, or you can actually select point, hardpoint location, or you can import from a file. If you have a lot of positions that you want to include, you can import them as well. So if we just choose this, and then we come on one of these model lines, now we might have to turn the model, but let's say I want to be, roughly, if I want to capture this curvature, maybe here. Okay, so I've added 1 point, I'll add another one here. So it gives me this 0.38 and 1.1. I'll turn off the selection, and I'll just go ahead, highlight this, and regenerate the current SEGMESH. Now if I do that, you see it pulls this forward because now we have a constraint on this location, and it tries to divide everybody else evenly. So this isn't too bad if this is what we like. If we wanted to add one more in here to try to smooth out these divisions, we could just simply increase this to 12 and do it again, and that should, okay, this time it's going here because this distance happened to be the greatest distance first. It's going to start subdividing that. Or we can reduce it. So another way is to go backwards and try and see if we get a better distribution. So this isn't too bad. We could enforce another one. That would be another way. But we won't worry about that. In the meantime, I think 11 looked a little bit better. For now, I'll just go ahead and stick with 11. Okay. So now the next SEGMESH that we want to add, we're going to click. And the way to do this is we want to start where we left off and then go to some downstream point. So if you double click on the end position of the last one, right mouse click, say copy, double click on the start of the new one and say paste, then we can start exactly where we left off. And then for this one, I'm going to double click, but I'm going to go in the model and pick this juncture point. Now here's something that I'm also noticing. This particular orange line here should have also intersected back into the model here. Otherwise, we can't get a correct panel. So what we want to do is at this point we're gonna stop and make that repair. So we come back up here. We see that it's the third line. I'm going to turn on the nodes, and then we're going to delete these elements in this region. So we're going to take this out, take this out, take this out, and we're just going to back it off so we can try to smooth out the intersection point. So maybe approximately there. And for this one over the canopy as well, we'll take this out, otherwise we'll have a kink here. Okay. Then we will go back to 3. We're going to add now. So we're going to add from here to this point and then over to this point. And turn the nodes off, click 3 times to unselect. Okay, so now we have a point that'll branch. So we come back here, we double click on the endpoint, and we're going to select that as our endpoint, and we're going to set 2 cuts here. And now we're going to say generate all the SEGMESH, so it does both segments. And then we see that we get the first one plus the second one. And again, to stress the importance of having points come together and separate cleanly, you need to ensure that. All right, so and then if you look at this, if you turn off the lines, you can see how the cuts are generated. All right. So then we add another one, station 3. Again, I'm going to play the same game. I'm just going to copy this guy, paste it as my starting point, and then my ending point. We're going to come to the next transition, which is right here. Here we have a separation, so we're also going to have to make a correction here. So I'll do that first. You can see that when you zoom in, didn't see it when we were zoomed out. We can check all of them while we're at it. Make sure that the rest of them, like here we also have to make a fix. So we'll do that at the same time. Here we have a jump. If we define this as a transition point, we would need to make the fix. So wherever you have a transition point, this is definitely going to be one, but this one's okay. And we could also just do hard points. So if we don't do SEGMESH endpoints, then hard points aren't as critical, and it will be fine as long as the hard point defines where the 2 points come together. But it's always best to, especially if you're going to generate a ZEUS input, to have them come together. So I'll just go ahead. There's three places to fix. To avoid any headaches downstream, we'll just go ahead and say, okay, so this is number 4. Turn it on. And all we need to do here is delete this guy. And then number 4, we're going to add from here to here. Okay. And we come on the back side, make the little repair. And we'll drag it from here to that point. So number 4, delete this guy. Number 4, we're going to add from here to here. Okay, so 4 is done, and then we need to make a correction here on this guy, which is probably 3. So turn on the points, delete, and then 3 we're going to add from here to here. Okay. So now we should be continuous on these lines, and I'll make sure on this one, yeah, we're good everywhere else. Okay, so we'll have the next transition point, we'll be looking at it from the side right here, because we have a split, and there's going to be a real small one. You're going to have a small panel width here because we go from here to here, and then it'll be here, and then up to us. We can jump, but if we want to capture this edge, we would need to use each one of these points. So I'll pause at this point and go ahead and define all of these as SEGMESH, and then we'll return to continue. So after adding all of the SEGMESH entries and adjusting the cuts to the desired cuts, we can end up with a model like this. Some of the points needed a little bit of adjusting in here to make sure that they come together, and once that was done, then generating the panels is straightforward. So at this point, you can turn the lines off to see the preview. Each one of these different color sections is a different SEGMESH. You can highlight them by turning this on and then selecting, for example, 1. You see it highlights in orange. 2, second SEGMESH, and so on. And we can go through. Now this SEGMESH is a little thin on the width, but that's because we had to define this curvature. We wanted to capture this region. So if we look at this now, then we can see that from these 2 extra lines, we were able to capture the front windshield region, this flat region, as well as the bubble from the canopy. So if we want to view this in, for example, a ZAERO input deck, we can select to file to output the data, and then we can click on generate all SEGMESH. Program will ask us for a file. Let's say, for example, we have a dummy folder here and a file called fuselage, and we'll save on top of that one. Replace it. So once we generated that, then we can come outside of here, go into there and see what the program generated. So this was the file that was just output, and if we include that in a dummy input deck here for ZAERO, this happens to be just a snippet from the first Flutter test case. But if we use a sol -1 to process the geometry only and we include a plot arrow card so we can output in TechPlot format the aerodynamic panel model, and then we include the fuselage.dat file that we just generated. So if we run this file through ZAERO, I'll go over to that directory and then say ZAERO test.imp and run that. And when this finishes, then we can look at the TechPlot generated panel model to ensure that that's what we were after. So there's not too big of a model. It should be done here in a second. Then if we have TechPlot, if not, you can also use ZONA-MV to load TechPlot files, either way. So we have to adjust the axis because TechPlot has this bad habit of scaling to some weird scale. So here's a scale of 1 to 1, which is what we want. We can shade the model. These dark lines demarcate the SEGMESH regions, and so this is the model that's generated. These green lines here are from the finite element model output. We'll just turn that zone off. Okay, so we can see the model only. So this is what we generated using ZONA-MV. So on a final note, if we come back to ZONA-MV and we want to generate a ZEUS model, assuming that all our transitions are tight, which we've ensured for this model now, we can select to output a ZEUS bulk data input deck of the BODY7 model and SEGMESH. The difference is that for ZAERO we had multiple SEGMESH, so each one of these colored regions is the one SEGMESH that we defined here in the SEGMESH list control. But for ZEUS, you can only have one single SEGMESH. So you end up with actually, on all these transitions, multiple lines that come through together. Now the program can automatically do that for you and generate it. So you can select ZEUS, and this time we'll select to the data tab. Now the data tab is emptied out here. And then we say generate all SEGMESH. Again, we have full from half and preview set. So we generate all the SEGMESH, and the program will output all of the bulk data, which is the BODY7. If we scroll up here, we have a chord for the BODY7, the BODY7 card, and the BODY7 refers to this single SEGMESH. The SEGMESH defines the AEFACT cards, which define the Y and Z coordinates at each station, X axial station. So these are the X station values from 0 all the way out to 195, and these are the corresponding AEFACTs that define the YZ coordinates. And so we have all of that output here, and what you can simply do is if you output to the data tab, you can right mouse click and say select all, say copy, and then you can use something like Notepad and paste. So you can paste your input deck here and then save it to a file, include it in your input deck, or you can paste directly into your input deck. So there's several options available there. So that's the process to generate a body model. Okay, so in this final video segment, we're going to show you how to import, export line segment data, how to set up the A-chord definition, and setting up user-defined circumferential cuts. So I'm first going to just load back the last model that we had, which was the A10_body3, and we'll turn the line segment on so we can see the line segments that we have. So in terms of importing and exporting, what this option is if you have line segment data defined, for example, if I click on this first one, we see it highlights this line on top that we set up. If we want to export it, we just can select the export button. We'll call it line 1 and save it. Now if we go look at the data that was saved, it outputs the data like this. So it gives you the entry, the ID of the line segment, the number of subsegments for that line segment, and the options that were set, the color, and then all of the points. So you have the option of pulling out that line if you want to use it within another program or a spreadsheet or whatever you want to use it for. You can extract that curved data, if you will. And we also have some MATLAB scripts to generate body data, and this line segment data can be used there as well. So that's one option for exporting. Another one is you can save the data. So once you've exported it, you can always import it back either in another model or for the same model if you happen to be redoing something later. So for example, now that we have 17 defined here currently, if we import the one that we just exported, then we see that it pops it in down here at the bottom. And again, it's the same line. So now we actually have two lines here, number 1 and 18, that fall in the same place. So I'm just going to go ahead and delete it here because we don't need to have it twice. Okay, so that is the import and exporting of line segment data. Now, one thing I want to show here, if you have an entry highlighted and then you go to generate the model or the paneled model, and you're going to get an error message. So I'll just show you here. For example, let's say we want to generate the first one. It'll come up like this, and it says you need to have at least 3 line segments to generate a body 7 from. And you say, oh, what's that? Well, no reason to panic. All it means is that there's something that's selected up here in the list box, and it happened to be the first one. And you can see it because it's highlighted here in the view. Again, to unselect it, you triple click in the white space, it'll unselect, and now you're free to generate the SEGMESH data. So we can click on it and it'll generate the first one. Now you say, well, what's the purpose of that? Well, the reason that's there is because you have the option within the line segment data list view to down select lines that you want to generate the model from. So this is just kind of a sub option, if you will. So let's say, for example, I have 17 lines here, but I want to do every other one and generate these panels for every other one rather than all of them. You have that option here. You can select the entries you want. I'm holding the control key, and I'll just go every other line. And then we'll come down here, select 15 and 17. And now we'll tell the program again to just go ahead and generate the current. Oop, I shouldn't have selected that. I wonder if it'll retain it. Let me see. Yeah, it retains it. So even if you took the highlight off, it retains it. So here we see that it went every other. If we turn the line segment data off, you can see that it gave us a model, but only using half the lines, skipping every other. So we have that kind of option in here, and that's the reason why that message will pop up occasionally. Just triple click in the white space to take off the focus, and then you can generate the SEGMESH. We have to say one here. Okay, then it'll generate it with all of the lines included. All right, so A-chord definition. What's that about? Well, the A-chord is here, and by default we have 0, 0, 0, which is the nose point of the vehicle. And for this particular fuselage, that's correct because we originally shifted our model, and we shifted it to be located here at the nose at 0, 0, 0. So this is fine for our case. But sometimes you have an option. Let's say, for example, we wanted this model defined 10 units downstream, so we could shift our A-chord position and generate it, and it'll give us the axial stations relative to our A-chord. And this is useful, for example, if you're setting up an underwing store or engine model, and you want to have an A-chord definition to define the origin of that particular component. So you can use the A-chord for that. Now you can either key the values in here, or you can select from a model point. So if you select from the model point, you just go in on your model, click, it'll populate the XYZ based on that point. As an example here, if we put in a value of 10, and let's say we have a y value of 0 and a z value of 0, so we're just shifting by 10 units. And I'm going to delete the data tab here. Okay, so let's regenerate the first segment. Okay, now if we scroll up here, we see then that the A chord is defined starting at x equal 10. So in order to generate this model, we have to start our x axial station at minus 10. So in essence, we're starting back at 0. So you see these values then account for the A chord location that you've defined. And then finally, setting up the user-defined circumferential points. What's that about? So I'll set this back to 0 here. Now if we come down, for all the stations that we had generated for the SEGMESH, they were all auto-generated except for one station. We had the 5th station, which was up in this tight region here. We told the program use user-defined. Now if you right-mouse click on it, if you check set to auto, it'll set it as auto. Set to user, it'll set it as user. If you go edit user selected circumferential lines, it brings up this edit box where you've defined the order of the lines. Okay, so you have to select them to pick them in the box. Now these are already selected. If you have them selected, when you click on one, you see it highlight in the model, and then you can actually use the arrow key to shift through them. So you can see we're telling the program, I want you to cut the circumferential cut lines through these body segment lines in this order. Okay, so then we go pink, and then the black there, the green, the orange, pink, and then we come up on top of the model here, all the way up to the center line of the fuselage. So that's the order that this one was defined. And if you want to define them, all you need to do, for example, on the last one, we have this segment that goes from the very end. We'll just go ahead and set it up as a user, even though auto works fine, to show you the process. So we set it as user, then we edit. Now it comes up with an empty box because we've never set it up yet for this SEGMESH station. And then we'll just go ahead and select these lines in the order that we want the program Alright, I'm going to get through all of these here. Sometimes if it doesn't select as easy, just rotate the model a little bit and then it'll help your selection. So one, pink, and then green. Okay, so we have the 15 here, and I like to do a sanity check again. So you can even scroll upwards. So we'll start from the top and go down. Make sure that we have them all. So we're on number 9107. Let's turn the model this way so we can see it. Okay. Perfect. So we have them all. Okay. And then we could say OK, and now it's saved as user defined here. So if we want to generate, again, it'll just generate the same thing as it would have done for all. We'll say for auto, sorry. So we'll have it generate the model. All right, and then turn off the line segment data, and then we see that we get the same. So the program, but we told the program this time what order and which lines to use to generate the circumferential cuts. So to prove the point of changing the order or even removing entries, what happens for ZAERO, the SEGMESH actually don't have to be continuous from one to the next. So for ZEUS they do, but for ZAERO they don't. So if we were going to generate a ZAERO and we wanted to alter that, you can use this feature to do that. So for example, I'll just go ahead here, I'll turn the lines back on, we'll go to this last SEGMESH number 10. I'm going to edit the preferences, and this time let's just take out one of the lines. So we start from the top, and let's say we want to take out one of these lines here. So there's the top line, 2, 3, so let's say we take out the fourth one, number 14. So I say delete, and it's gone. So it's going to skip that one. I say OK, and then I once again generate all SEGMESH. And once it finishes with that, we can turn this off. And then indeed we see here that it has skipped this line. And since we're generating a full model from half model, we'll see the same effect on this side. So we have a new SEGMESH that's actually missing this line. So like I said, with ZAERO you can get away with this kind of thing, but with ZEUS models you can't. So anyways, you understand the concept here of using user, and you can also use this feature when you need to guide the auto. If the auto can't figure out the order automatically from the counterclockwise point of view, which it tries to determine, then you have to manually go in and pick the lines to tell it which ones to choose. So that's the process.